In this video, we're going to start looking at parabolas and how to find their component parts. So here we have a variety of rules, starting off with the definition of what creates a parabola. Basically, this shape is created by looking at all of the points that are an equal distance from one special point that we call the focus and another special line that we call the directrix. And I'll show you some examples of that image in a bit, but if you look at all the points that are the same distance from these two objects, it creates that parabola shape. Now we have two different standard equations here because there's the version that opens up or down and the version that opens left or right. So to distinguish between the up and down case and the left and right case, you'll be looking at which variable is squared. So if it has an x squared in it, but a y to the first power, it's an up or down one. And between those two cases, you'll be able to identify by looking at the p-value. If that number is negative, it's the down case. If that number is positive, then it's the up case. And if your parabola instead has a y squared in it, then it'll be the same thing. Look at the sign for p. If p is a negative number, it goes left. If it is a positive number, then it goes right. Now, some things the two standard forms have in common. For example, the vertex is always the h and the k value. And you'll notice that h is always the number that's attached to the x variable, and k is always attached to the y variable. Now, the x and the y may switch, but h is always by x, and k is always by y. So this is kind of like the point where the parabola splits off into two different directions. And then I have two formulas that look fairly similar for the focus and the directrix. You'll see that they both basically start from your vertex coordinate. And then I've tried to give you a shortcut rather than have you memorize these different rules. If you notice that when p is touching the y variable, then you're going to take that p value and add it to the y coordinate. So add it to whatever it's touching, and that gives you the focus. Or subtract it from the y coordinate, so k minus p, and that gives you the directrix. That's why here on the side I've tried to specify that for the focus you add p, and for the directrix you subtract p. And that rule will be the same if you're dealing with the other set of equations. When p is touching x, then start with a vertex and add p to the x coordinate for the focus, everything else stays the same, or subtract p from the x coordinate for the directrix. Also note that the directrix is an equation of a line, so that same variable, if p is touching y, then it's going to be a y equals equation. If p is touching x, then it will be an x equals equation. You have to put the y equals or the x equals because we're specifying an entire line. It's kind of like an asymptote that the parabola will avoid. And then the focal width is the absolute value of that number you see in front of the parentheses on the right-hand side. Like I said, whether p is positive or negative will determine the up and down or left and right case. So the focal width is always the positive version. Take the absolute value of whatever 4 times p equals, and that'll be how wide the parabola is at the point of the focus itself. And then down here is the tip that I was just giving you guys. If the equation has p next to y, like in this case, then add p to the y coordinate for the focus. So take the vertex, add it to the y coordinate for the focus, or subtract it from the y coordinate for the directrix. Here's our first example dealing with parabolas, and we're going to be focusing on how to identify those component parts: the vertex, focus, directrix, and focal width. My advice to begin these is always to start off by labeling the h, k, and p values. Now this first example, it kind of looks like we don't have some h and k values, so just to point this out, when you have something like this where you don't see numbers being added and subtracted, it may help you to write it in this form. Nothing is being subtracted from the x value, and nothing is being subtracted from the y value, which means that h and k are both 0. So when you don't see numbers being added and subtracted, it just means that either that h or k value is 0. It can help you to write it this way, but this is the way that will usually show up in the equations or in the examples. So my first piece, like I said, I really recommend that you guys start these off by saying, what is h? In this case, it's 0. What is k? So the number that's being added or subtracted from the y variable is also 0. And then the number that's out front, whatever's being multiplied by the first power variable, whether it's an x or a y, will change. So this number is 16, and that's what 4p equals to. So 4p is equal to 16. Then we just need to divide both sides by 4, and that gives me that p equals 4. So now that we've identified the important numbers h, k, and p, we just need to start going through and following the formulas for the vertex, focus, directrix, and focal width. You could do this by just having the formulas next to you and plugging in the numbers in the appropriate spots, but what I'm going to try to emphasize more to make it easier for you guys to memorize, I'm going to try to focus on how to do this without just plugging in so that you don't have to memorize the equations so much as the process of what number gets added to what. So do note that this is an x squared equation, which means if you are plugging into the formulas directly, you need to make sure you're using this left-hand column. This is the x squared side of formulas. So my rules are all written here, but I'm going to do plugging in by using some of the shortcuts and the tips I was referring to down here. So first up is the vertex. This is probably the most important piece because everything else is based on the h and k coordinate we get from that. And in these cases where we don't see a number being added or subtracted from x and y, it's just the numbers 0, 0. Both my h and k value are 0. Next for the focus. So now we need to start paying attention to what the p value is touching. In this case, p was attached to y to the first power. So whatever p is touching, that's what we're going to be adding and subtracting the numbers to. So for the focus, it's an ordered pair. My p value is 4, so the number I'm going to add is this number right here, 4, and I'm adding it to the y coordinate of my vertex. So if I take the coordinate I have for the vertex and add 4 to the y coordinate, I get the point 0, 4. Similarly, I'm going to do the directrix by saying, well, p is 4, so I know I need to subtract this number from something. And again, the reason I'm subtracting it from the y coordinate is because that's what p is touching. P is coming from this value, so I'm going to write the equation y equals, and then it's your k value minus your p value. So the y coordinate is 0, subtract 4, and you get -4. And then the focal width is just the absolute value of your 4 times p number. So remember that absolute value always takes a number and makes it positive. If it's already positive, keep it positive. If it's negative, it flips it to positive. So the absolute value of 4p is just 16. And the focal width, concept-wise, just to remind you, this is how wide the parabola is or how far across the length of the parabola is at the point that passes through the focus. So those are the component parts when h and k are 0 in an example like this. So here's a more complicated example where now I do see numbers being added and subtracted from the x values. So our first step is to say h is the number that's always attached to x. Remember that the formula says x minus h, so switch the sign on this number. So since I see a positive 3, that means h is -3. K is the same idea. It's y minus k, so flip the sign on whatever you see attached to y, and that will be your k value. So in this case, k is a +2. And then 4p is the number being multiplied by the first power variable. If it's multiplied by the second power variable, we have to do something different first. But I have x to the first power, that's the first power. So 4 times p is equal to 4 in this case. If you solve this equation, divide both sides by 4, you get p equals 1. So please start off by labeling h, k, and p, and then we can just go through and fill out the 4 component parts. So first, the number that requires the least amount of work, our vertex is the h and the k value. So the ordered pair on this one is just -3, +2. So that's the point on the graph where the parabola kind of splits off in 2 different directions. Next, when we start filling in the focus and the directrix, remember that for the focus we're adding p, and for the directrix we're subtracting p if you were looking on the formulas earlier in the slide. So on this particular example, my p value is 1, and notice that that number is attached to x. So when I'm adding and subtracting the value of 1, I'm going to be adding and subtracting it from the x coordinate of my vertex. So my x coordinate is -3. If I add 1 to that number, I get -2. And I'm not changing the y coordinate, so that stays as 2. For the directrix, now p is touching x, so this is going to be an x equals equation. And instead of adding p to the x coordinate, I'm going to subtract it from that number now. So -3 minus 1 is -4. And then the last piece, the focal width, is just the absolute value of this number. The absolute value of +4 is 4. So it's the absolute value of 4p for your focal width. So that's a second example. Now we're seeing how it gets a little bit more complicated with the computations, because now you're not just adding and subtracting from 0. You have to start with the vertex coordinates and then add and subtract p from the appropriate variable. Always look at what p is touching to figure out what to add and subtract it from. Now, one last example, we're finding the same component parts, but there is something that's a little tricky and it's easy to miss on this question. If you look carefully here, we have a number being multiplied by x squared. But if you look back at the formulas from earlier, the 4p value should always be getting multiplied by the first power variable. It's not attached to the squared variable, no matter which set of equations you're working with. So if you have y squared, then p must be touching x, and vice versa. If you have an x squared equation, then p must be touching y. So the first thing we need to do on this equation is actually to get it into the right form. We need to do opposite operations to move that negative 1/2 to the opposite side of the equation. I'm also going to flip which side the x squared and the y are on, just to make it match the formulas a little bit more. So I'm going to start this off by saying x squared equals, the opposite of multiplying by negative 1/2 is multiplying by negative 2. So if you multiply both sides of the equation by negative 2, you get negative 2 times y. Now this matches the formula for our parabola, our standard formula for parabola. This is another one of the cases where my h and k values are 0 because I do not see anything being added or subtracted from them. So since this is in the correct form, we can say, all right, that means h equals, number being added or subtracted from x is 0. K equals, and the number being added or subtracted from y is 0. And then 4 times p is equal to, so the number being multiplied is negative 2. If you divide both sides by 4, we're going to get a fraction on this one, so this is a little bit harder to work with. So I'm going to get p is equal to negative 1/2. So after getting all of our variables labeled, the vertex, the first thing we want to fill in, the h and k values are both 0 on this one. Then for the focus, my value is negative 1/2 on this one, and I'm going to be adding and subtracting that number from the y coordinate because p is touching y. So if I take the coordinate 0, 0, and I add a negative 1/2 to the y coordinate, 0 plus negative 1/2 is negative 1/2. For the directrix, I need to write an equation. Since p is touching y, it's going to be a y equals equation. And then I'm taking my y coordinate and I'm subtracting p this time. So now 0 minus negative 1/2, the double negatives cancel. That means y equals 1/2. And the last piece here, we're doing the focal width. That's the absolute value of 4p. Well, this time 4p was a negative number. It was negative 2. So if you take the absolute value of negative 2, don't forget to flip the sign. That means that this parabola is a length of 2 across, passing through this coordinate. So that's it for the examples on how to find these component parts, the vertex, focus, directrix, and focal width of a given parabola.